Chapter 8 is oxidation and reduction. If you remember back in Chemistry B, we talked about oxidation numbers, and we looked at the oxidation numbers to see if something was oxidized or reduced. In this book, we use oxidation numbers a little bit, but that's not the only thing we use. We also look at oxygen and hydrogen to see what's happening. Okay. The term redox is just reduction and oxidation smushed together. This involves two processes. Oxidation and reduction must occur at the same time. So oxidation, if you remember, is the loss of electrons. Reduction is gaining the electrons. And they both have to occur at the same time. Okay, like I said before, this book does things a little bit differently. Both of them are correct, they're just different viewpoints. What this is that we can gain or lose oxygen atoms to see if something is oxidized or reduced, the gain and loss of hydrogen atoms, or we can look at the gain and loss of electrons. So this is specifically what's going on. In order for oxidation to occur, and we're looking at a reaction, we're looking at reactants versus products. If the reactants gain oxygen from the reactant side to the product side, then oxidation occurs. If it loses hydrogen, the same thing happens. And if we lose electrons, and all of these things get oxidized. Reduction is just the opposite of what happened over here. So here's reduction. So reduction, if we lose oxygen, if we gain hydrogen or gain electrons going from the reactant to the product side, then your substance is reduced. Okay, this is just a reminder of things we did in Chem B. For the oxidation, if we look at oxidation numbers, an increase in oxidation number means that we have a loss of electrons. And so remember, that's an increase in charge. So right here, the only two things you need to know about oxidation numbers are right here. If you have an elemental element, which means that it's just by itself, it's always going to be 0. So this is anything by itself, or let's say you had like 2 chlorines, and it's the same element, just multiple atoms of the same element. Right here, whenever you have a monatomic ion, it's always the charge of that ion. So right here, it's a +2, so that's a +2. So if you compare the zinc on the reactant side to the zinc on the product side, your oxidation number has increased. And because it's increased, this is showing oxidation. The opposite of that is reduction. If we have a decrease in oxidation number, it means that we're actually gaining electrons. Because remember, electrons are negative, so a decrease means we're gaining. And so that's going to be a decrease in charge. So again, monatomic ion, that's a +2. An element all by itself is 0. So if we go from a 2 to a 0, that's a decrease, or we have reduced the number. And so this is going to show reduction. And those are the only two viewpoints of oxidation numbers that you need to know for this chapter. Okay, now we're just going to do some practice problems. So we're going to compare the same substance on both sides of the reaction. So right here, we have magnesium. And on the product side, we want to look at magnesium as well. So notice that on the left, we have no oxygen. On the right, we have an oxygen. So we have gained oxygen, right there. And so that means magnesium is oxide. Then the next thing we're going to compare is CO2. And so notice how we're looking at the carbon here and the carbon. You want to look at things that have oxygen and hydrogen, but that's not what you're comparing when you look at both sides. So we go from here to here. This carbon dioxide had oxygen. Over here, the carbon does not. So we have lost we've lost oxidation, so this is reduction. So magnesium is oxidized and the carbon dioxide is reduced. Okay, next example. Oh no. Okay, I don't know what I just did, but we'll get this fixed. Okay, next example. Let's compare the carbon on the left side to the carbon on the right side. Notice here we have 4 hydrogen atoms, and right here we have 6. So if we compare those two, we have an increase in hydrogen. So if we have a gain, that is going to show reduction. So that substance is reduced, the C2H4. The N2H2, we're going to compare that to the N2. So notice that the nitrogen is the two things. Here we have hydrogen on the left, but no hydrogen on the right. This means we've lost hydrogen, so this will be oxidized. Okay, next example. On this one, we don't have any oxygen or hydrogen, so we're going to look at electrons. So let's compare what we know. Copper to copper. Right here, copper is in its elemental form, so it's a 0. On the right side, it's a +2 because it's a monatomic ion. Notice that there is an increase in oxidation number, so copper is oxidized because remember an increase means we're really losing electrons. And then the silver on the reactant side is a +1. On the product side, it's a 0. So 1 to 0 means that we have actually gained electrons, which shows reduction. Okay, now note how we're not looking at coefficients at all. We're only looking at either the substances that we're comparing, or we're looking at the oxidation numbers, what's happened with the electrons. Okay, next example. This is a combustion reaction. So right here we have oxygen and hydrogen, so that's what we're going to focus on right here. We have our carbon with a hydrogen. We want to compare the carbon on the right side. So here, notice how we're starting with hydrogen, but we don't have any right here. So right here we have loss of hydrogen. But notice how we've gained oxygen on this side and we have gain of oxygen. Sometimes more than one viewpoint will occur, and they should always complement each other. So let's look at this. If we've gained oxygen, lost hydrogen, those are both viewpoints of oxidation. So we're going to say that the C2H4 is oxidized. And now we're going to look at oxygen and we're going to compare it to the water. So here, if we look at things, we had 2 oxygen here. We only have 1 oxygen here. So right here, this means we have lost oxygen. And then there's no hydrogen on the left, but there's 2 hydrogen on the right, and we have gained hydrogen here. So again, these viewpoints should go together. So right here, lost oxygen, gained hydrogen, this is reduction. Okay, next example. This is our glucose. So on this one, we're going to look at C6H12O6 and compare it to the carbon dioxide on the right side because we want to look at the carbon and the carbon. That's why we're comparing these two. And now we want to look at the oxygen and the hydrogen. So here we have 12 hydrogen. Here we have no hydrogen. Okay, so we can say that we have lost hydrogen. Then our oxygen goes from a 6 to a 2. Because remember, we're not looking at these coefficients. So 6 to 2 means that we've also lost oxygen. Okay, we go down here and we look at lose hydrogen and we look at lost oxygen. This is confusing because one's oxidized, one is reduced. So we need to make sure that, like, this is a problem. So let's go ahead and look at our other reactant and see what's going on there. So right here we have oxygen, we're comparing it to hydrogen, so let's look at what's happening here. Here we have 2 oxygen to 1 oxygen, so we have lost oxygen. We have no hydrogen, but 2 hydrogen here. So here we have gained hydrogen. So let's look at what this is doing. So lost oxygen, gain hydrogen, those are both under reduction. I'm going to go ahead and put reduced right there. Okay, and then let's go back to the glucose. This is still a problem because lost hydrogen is oxidation, lost oxygen is reduction, and that we can't have conflicting viewpoints. So with something like this, what you have to do is you have to do ratios. So if you look right here at the C6H12O6, notice how we can reduce those subscripts. So we're going to reduce them by 6. So if we divide all of this by 6, we're going to divide by 6, we're going to get 1 carbon, 2 hydrogens, and 2 oxygens. I'm sorry, we're going to get 1 oxygen. I apologize. Okay, so we get a 1 to 2 to 1. When we compare this to our carbon dioxide over here, for every 1 carbon, we get 2 oxygen, because again, we're not looking at the coefficients, we're just looking at the amount. So now let's compare what's happening. If we compare this, now we have 2 hydrogen. There's nothing over here, so we have still lost hydrogen. Our oxygen now goes from a 1 to a, oh, look at that, a 1 to a 2. So that means that we have actually gained oxygen if we look at a ratio. So lost hydrogen, gained oxygen is oxidation. So we can feel confident that the sugar is oxidized in this example and the oxygen is reduced. So again, if you have differing viewpoints, look at ratios. Okay, let's do another example here. Okay, on this example, there's a lot going on. And so when this happens, again, you want to compare the same elements. So right here, we've got chromium and oxygen. And on the product side, here's your chromium. So we're looking at these 2 chromiums. In these examples, what's happening is the hydrogen ion and the waters are just there for balancing purposes. So we're not going to compare those to figure out what's happening. So right here, our chromium to our chromium, here we have oxygen, there's 7, and here we have no oxygen. So again, what's happened here is under this comparison, we've lost oxygen, which is reduction. Okay, let's look at our other substance. Our other substance here is C2H5OH. We're going to compare it down here to the carbon that's here. Okay, carbon and carbon. Now let's look at the oxygens and the hydrogen. Here we have a total of 6 hydrogens, and here we have 4. So here we have lost hydrogen, and then our oxygen has gone from 1 to 1. That's the same. So we're just looking at losing hydrogen. Losing hydrogen shows oxidation. So this is an oxidation substance, the C2H5OH. And the other one is the reduction. Okay, if you have any questions, let me know. I will do another video with more examples on it that I will post later. Okay, good luck.